I'm pretty sure not.
When we look at our plate boundary, obviously one of the first ones we're going to pick up on is divergent. And this is kind of where the theory of seafloor spreading kind of gets unified under plate tectonics, because this kind of makes sense. And we've seen a lot of the same features with seafloor spreading that we're going to see here with divergent plate boundaries. So again, what does it mean to diverge?
Go apart.
Split apart. And that's all that's happening is when two plates are moving apart. And when they do that, they form rifts. And a lot of times, we're normally going to see most divergent plate boundaries, most, not all of them, but most of them occur on the sea floor. Most notable would be where? Where do you think it would be the most obvious divergent plate boundary? Between where and where?
Underwater or above water?
Underwater. Well, where?
The Mid-Atlantic Ridge.
Yeah, Mid-Atlantic Ridge is a perfect example of divergent plate boundaries. So your Mid-Atlantic Ridge is where basically North America, South America are pulling away from Europe and Africa. And when they pull apart, again, we kind of get that natural ridge that starts to form. And that's simply going to happen when it's underwater. However, there are a couple of places where this does occur on land. And the most notable is the East African Rift Valley. You can kind of see there the Red Sea, Persian Gulf. Those are two examples of divergent plate boundaries. And it's all part of the same system. And so when we look right here, you can come in right in here, right at the Gulf of Aden. And right in here, we have Djibouti, which is right here in Africa. And if you can follow this, you can actually look at a map today, you can almost follow the rift itself without even seeing the lines. Because then there's this whole chain of lakes that work their way down the east coast of Africa and come out way down here. And again, we can see the same thing right here with Madagascar, pulling wood from Mozambique. And the reason for that rift valley is very simple. As my two plates pull apart, what's going to, if I'm pushing in, it's keeping that middle section locked in, right? A lot of friction. You guys ever tried to carry things like this before? Squeeze it really tight, it won't fall out. That's what, as soon as you release that tension, oops, there we go, perfect example. Where did it go?
Down.
It simply fell out. So what happens is a lot of times when that's happening, that middle section of land drops down, and when it does that, what fills the gap? Think about it. It's now become the lowest place in the area.
Water.
Water, right? Because water flows from high places down to low places, right? High potential energy down to low potential energy. And so when we look at that, that's how we get these chain of lakes to occur in East Africa. We can see the same thing with the Mississippi River. The Mississippi River is an ancient plate boundary where we had two pieces of land that at one time were pulling apart. And that whole region dropped down and became one of the largest rivers, actually the largest river of North America. In fact, we still have earthquakes that occur along that plate boundary, including this little town right here called New Madrid. And then if you're not from Missouri, you would call that New Madrid. They call it New Madrid. And that particular fault zone still has earthquakes along it today, which is how we sometimes register earthquakes in Fort Wayne. So a lot of this is still going on today. Now, one of the worst earthquakes in human history, I shouldn't say human history, but recent history, was in the middle of the 1800s, and the earthquake was so severe, it actually forced the Mississippi River to alter its course, and it started to flow northward again instead of south. So this is still a very strong fault zone along the Mississippi River. Now, another example of divergent plate boundaries, again, it's really easy to see the divergent boundaries when they're on land, because typically you're going to see a long chain of lakes. Now, what do we have sitting here?
Over here.
And what do we call that river?
St. Lawrence.
St. Lawrence, because it's called St. Lawrence Seaway. And if you think about it, it's really narrow here, but as it works its way up to the coast, what happens to it? It's slowly widening up, right? And what this is actually an old fault line, divergent fault line, that wraps itself around the entire Midwest region. So a lot of times we were told as kids that, hey, glaciers formed the Great Lakes. Well, not really. They filled the Great Lakes, but they certainly did not carve the Great Lakes. The holes were already there. All the glacier did was fill it off with water. So when we look at this, there's actually a whole series of fault lines. And in fact, right here, when we follow this around Lake Michigan, through Huron, the divergent boundary actually shifted its direction. And that's how we get the Great Lakes. These are all divergent boundaries between the upper part of North America and the southern part of North America. And so those are examples of rift valleys as well. All right, so again, questions on that before we move forward onto convergent boundaries?
No.
Coleman?
So could an oceanic plate eventually become a land plate?
No, because what will happen with the oceanic is it will be completely subducted between two continental plates.
Okay.
Great question, though. And we'll see an example of that later.
Well, I mean, it kind of did with like the Tethys Sea.
Tethys Sea is an example of that. Yep. For the most part, it'll get subducted. Some pieces of it get kind of scraped off the top. And I don't have a map of this, but that's kind of happening with the Pacific Plate. When we look at northwest of the United States, what happens there is, especially in Oregon, Oregon's a perfect state to use as an example for this. The islands on the Pacific Plate, as it gets subducted, they literally get scraped off. You can't really subduct an entire island, so they literally get scraped off, and they become part of the continental plate. And so when we look at the topography of Oregon, it's really this mixture of all these different islands that have been slammed into the North American coast over the years. It's a nice little conglomerate.